Hi guys. Okay, we do have notes to take today, so I will get my notes out in a second. But I actually want to start class with a little video. We are starting to talk about slope today, getting into what that means and how you calculate it. So I always show my kids this video. You can look it up on YouTube yourself. It's called Slope Dude. And I literally remember algebra teachers showing this video. And it's cheesy. The dude is old who narrates it, but it makes some sense. So I'm going to go ahead and share that with you right now.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive, puff, puff, positive, puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the Adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra, undefined. The uphill is a slope with a positive number. The downhill is a slope with a negative number. The flat part is a slope of zero. And the straight up and down or vertical part is undefined. This has been the Adventure of Slope Dude. Thanks for viewing.
Okay, so cheesy, yes, but it kind of makes some sense, you know? So we're going to get that in our notes. I'm going to pause here and cut to the notes. So get your notebooks out, okay? All right. So in your notebooks, go ahead and title it Slope Basics. My computer's a little bit laggy, but it'll pick back up. So Slope Dude. Slope Dude just kind of gives you a good visual of how to tell if a line has a positive slope, a negative slope, a slope of zero, or possibly a slope that's undefined. So we're going to draw that little visual that was on the screen. So we'll start with a little mountain type thing like that. And then a line that's descending down. And then we're going to do a flat part of the line horizontal, and then it's going to go vertical. Okay, and we're going to label all the parts and pieces. So I am going to draw a little stick figure, Slope Dude. Okay. And one thing to keep in mind is our Slope Dude always skis left to right. Meaning when I read a graph, and yes, that is something you do, you read a graph. When I read a graph, I look at it from the left to the right. That's how I know how to determine if it's increasing or decreasing. I go from left to right, okay? Just like you read a book, left to right. So if just this part of the graph, if I read it from left to right, it is going up. It is increasing. And for our little Slope Dude, the skier, what he is saying is puff, puff, positive. Okay, so if your graph is increasing from left to right, then it would have a positive slope. Now ski dude, slope dude, gets up to the top of this peak right here and he starts his downward descent. So when slope dude is at this part, he's going down the mountain. Okay. And when you go up a mountain, when you're skiing up, by the way, I've never been skiing, but think about, walking up a hill, puff, puff, positive. It's hard work, right? When you have to go up somewhere, it takes a lot more energy. But when you go down, it's a nice and smooth. You don't have to exert yourself too much. So that's why he's saying nice, negative. Okay. So nice and smooth ride down the mountain. Now, if you look at just that chunk though, from left to right in this little piece, it is going down, which means the slope is negative. Okay, so if you're descending from left to right, it's going to be a negative slope. Okay, all right, now let's talk about this flat part. Now, when you're skiing, which I've never been, but you can imagine, even when you're like sledding or something, when you're skiing, if it's flat, if there's no incline or decline, incline's rough, you have to get up there. Decline is best. That's when you have the fun, right? But when it's flat, when it's horizontal, you're just kind of walking on your skis. Like, that's not fun. There's no momentum. So this is why in this part, he says, this is zero fun. It's no fun. There's no incline to it. So that's just to remind you that a horizontal line has a slope of 0. Okay. Now, when slope dude gets right here, and I'm going to twist my notebook because I can't write sideways like that. Okay, here's your little slope dude skier. When he's skiing down this part, which is the vertical part, imagine him going down a cliff like that. And this should, I drew it kind of crooked, but it should be straight up and down, okay? A vertical line like that, when slope dude's there, he's going literally straight down. So that's when he says the worst curse word in algebra, which is undefined, okay? So on my little picture here, I'm just going to write him screaming because he's literally going off the edge of a cliff. And I'm going to write undefined. And that means a vertical line. If the line is straight up and down, not slightly tilted, straight up and down, it has an undefined slope. Okay, there is no slope. It's undefined. You cannot figure it out. Okay. So I'm just going to label this diagram in case you want to look it up and watch the video again. It's called Slope Dude, or The Adventures of Slope Dude. Okay. So it's just kind of a visual reminder for us, something kind of silly. Okay. So in the rest of this page, I have about this much room left. I'm going to split this into 4 quadrants. And no, it's not one big giant graph. We're just going to have 4 little pieces of information here. Okay, so we're going to start with positive slopes. Positive slope. So we would say that a line, a graphed line, has a positive slope if it is increasing from left to right. So I'm just going to simply write increasing. And then I'm going to say left to right. And if you're like me and want to abbreviate, you can write L to R. So if you read the graph from left to right, the line's got to be increasing for you to call it a positive slope. So let's go ahead and give ourselves a little visual here. You're going to draw a coordinate plane, which means like a coordinate grid. You draw your X and Y axis. Label your X and Y, always, always. And then you're just going to draw an increasing line. Now I'm going to show you with my pen that there's a million possibilities. But like this right here, if I were to graph it like that, that's an increasing line because from left to right, If slope dude was right here, he'd be going up the mountain, puff, puff, positive. Okay, it's increasing left to right. Now, even if it's a little bit more like this, notice how that's not as steep. Is it still increasing from left to right? Yeah, it's going upwards, not as quick of a change, but it's still going upwards. Or it could be like super steep, okay? It can't be vertical, no, but it's like super steep. That's also an increasing line. That's a positive slope. So whatever type of slope, or excuse me, it has to be positive slope, but however steep you want, that's up to you, okay? Okay, now we're gonna get a nice little visual of a negative slope. Okay. So a negative slope is exactly the opposite. It's going to be decreasing when you read the graph left to right. Decreasing from left to right. So let's draw a little visual here. Label your X, label your Y. All right, and pause the video if I'm going too fast. Okay, so negative slope, it's got to be going downwards. So starting on the left, ending on the right, it's got to be going downwards. It's got to be decreasing. So it could be a super steep slope. Okay, imagine slope dude skiing down that. Whoo, he'd go down quick. Okay, or it might be super shallow. Okay, not very steep at all, but he's still going downwards. It's still a decreasing slope, but you can't put it horizontal. Horizontal is the slope of 0. So it's still got to have a little bit of tilt to it. Okay, but you need to make sure it's going downwards, left to right. Okay. All right, now let's get into a slope of 0. So I'm just going to write 0 slope. So how you know if a line segment has a slope of 0 is if it's horizontal, and that means side to side. So you're just going to write horizontal line. So let's be clear on something. A slope of 0, like the number 0, does not mean that a slope doesn't exist. Right? It still has a slope. It's just its slope is 0. It's not steep at all. There's no steepness to it. Okay. So leave a little bit of room. We're going to have a little bit of writing here, but we still want to give ourselves a little visual of this. Okay. And for this one, obviously we're going to draw a horizontal line. So that's side to side. Now, your horizontal line, it can be below the x-axis, okay? It can be above the y-axis. It can go wherever you want it to go. It just needs to be horizontal. So something like that, okay? All right. And let's talk about why this ends up being a slope of 0. So what I want you to do is let's go ahead and let's put some numbers on your graph here. So I'm gonna just count by ones. Okay, so I'm just gonna count by ones so we can get some points on here. So if I were to ask you to identify some points that fall on this line, there are a bunch. There are a bunch of points on this line, an infinite amount of points along that green line. But I could see that right here at negative 2, 2. Whoops, silly Miss Meineke did not put her negatives in. Yikes. Goodness, my video is lagging. Sorry. Okay, so there is a point though at negative 2, 2. Go ahead and label that point for me, please. label that ordered pair, -2, comma 2. And then another point we might see is -1, 2, excuse me, yeah, -1, 2, 0, 2, 1, 2, 2, 2. That's a whole bunch of points. So I'm just going to go here at +1, comma 2. That also falls on the coordinate plane. Now, if we were to take those points and put them in a table, because we could do that, let's just see what would happen. So one of the points that I see is -2, 2. Set up an XY chart. I'm going to go ahead and plug in -2, 2. And then we could also plug in any other points that we identify on that line, such as 1, 2. Now, I could also put in other ones, -1, comma 2, 0, comma 2. But really, you just need at least 2 points to figure out a slope of line. That's all you need, 2 points. Now, let's go ahead and see what happens. We're going to go ahead and calculate the change in y and divide it by the change in x. Because guess what, my friends? Slope is the same thing as rate of change. Slope is the same thing as rate of change. So we're going to go ahead and figure out your change in y. So go to your little table there and figure out your change in y. So from 2 to 2, what was the change? It didn't change. From 2 to 2, it didn't go up or down. So I'm just going to write 0, okay? You added 0 to get there. So my delta y was 0, okay? Now let's go ahead and figure out our change in x. So go to the left-hand column, and from, goodness, the lag is driving me crazy. It's terrible today, worse than usual. So go to your change in x. From -2 to 1, that increased by 3. So my change in x was +3. So down below, when we do delta y over delta x, we got 0 over 3. Now I'll show you in a calculator because kids kind of forget which is which. 0 divided by anything is going to be 0. My calculator's coming up in a second. You can divide 0 by anything and it'll always be 0. The only exception to that is if you divide 0 by 0, okay? So 0 divided by anything is just going to get you 0. So we would say that the slope here is 0, okay? Now I want to go to kind of the opposite of this, which is an undefined slope. So for undefined slope, that's vertical line. So here we go, vertical line. Okay, so let's go ahead and do a little baby drawing of that. Set up your XY axes. And let's go ahead, we'll count by ones on this graph. And then we're going to do a vertical line that passes through 2 on the x-axis. So go right here and draw yourself a vertical line that passes through +2 on the x-axis. So we're going to use that. So if you see a vertical line, you have to think, oh my God, that's an undefined slope. Undefined meaning it does not exist. Okay, and I will show you why right now. So let's go ahead and just like we did over here, just to justify why like horizontal lines have a slope of 0, we need to justify why this is undefined. So let's pick 2 points, similar to what we did on the other one. Pick 2 points that end up on here. Now there's 5 million points, right? But there's one here at 2, 2. There's one here at 2, 1, 2, 0, 2, -1, 2, -2. There's a lot we could choose from. But let's do 2, 2, and let's do 2, 1. Let's just pick those. Okay, that's fine. Now, if I were to set up that information in a table, so draw a little XY table, let's plug in some ordered pairs. We had 2, 2 on there, 2, 1. And if you really wanted to, you could put in the others 2, 0, 2, -1. Okay. Something to notice is that your X values right here are always 2. They don't change because all those points have an X coordinate of 2. Whereas over here on the horizontal line, if we wanted to fill in some other ones, some other points, you would see that the Y values were all the same. So the change in Y was 0 over here. But in here, your change in X is what ends up being 0 every time. The change in Y, there's some changes in Y. So let's just do these first two. From 2 to 1, it's going down by 1. Sorry, this is like off my paper. From 1 to 0, it's going down by 1. From 0 to -1, it's going down by 1. So your change in Y.
So I totally made a mistake in my notes coming up. I wrote delta Y over delta Y, but you know better than that. It's delta Y over delta X.
Change in X here. The Y values are decreasing by 1. But on your X values, it's not changing. The change is 0. Now, do y'all know what happens when you divide by 0? I hope you do. You can ask Siri right now on your phone. She'll tell you anything divided by 0. So I'm just going to plug in this -1 divided by 0. Look. It says error, divide by 0. You can't divide by 0. When you divide, you are separating things into group. How can you take nothing and split it up into groups? Doesn't make sense. So dividing by 0 is impossible. Okay, it's error. And so what we say is we say that it's undefined. Some people say it does not exist, DNE. We're going to go with undefined in my class though. Okay, so here's the tricky part. I get kids that mess up between 0 and undefined, and those are two different things. So how do you know when it's going to equal 0 and when it's not? 0 on top, if you have 0 as a numerator, that's okay. You're literally this, I don't know why I didn't think about this, but like this is a beautiful, beautiful little visual. It is okay to have 0 on top. Look, 0's on top and it's okay. When you have 0 on top like that, it's just going to result in an answer of 0. But when you have 0 on the bottom, that's a no-no. That slope would be undefined. You cannot divide by 0. Okay, and in fact, I want you to write that in your notes. Cannot divide by 0. Okay, so this is just like an overview, how you know positive, negative, 0 slope, undefined slope. And then another thing we're going to cover in today's notes, which I'm hoping you remember from last year. We did a little bit of it the other day, but this is going to be called How to Find Slope from a Graph. Now, I am going to teach you how to find slope from other things, but I'm going to separate it into 2 videos. So for today, we're going to do how to find slope from a graph. The next video lesson, it'll be how to find slope from a table and from 2 points. Okay, but right now we're just focusing on graphs. I am going to have you write out some steps. So here are your steps. Step 1. And this will make more sense when we practice. Step 1, you're going to pick 2 points. And when I say points, I'm really talking about ordered pairs. Ordered pairs are your X, comma, Y points. So pick 2 points on the graphed line. Pick 2 points on the graphed line that actually land on the coordinate grid. Wow, that says grid, G-R-I-D. And what I mean by land on the coordinate grid is, you know how like on graph paper on a coordinate grid, it's made up of boxes and stuff. You want to pick points that actually land like in the crosshairs. You would not want to pick a point that's like in the middle of a box. You know what I mean? Okay, so pick 2 points that actually are good points, whole numbers. Okay, step 2. Starting from, I cannot spell this, sorry. Starting from the point on the left to the point on the right, comma, find the, and then you're going to do a little colon. There are a couple things that we need to find. So you start with the point on the left. So if these were the 2 points that I was using, if this was the line we were looking at, I would start at this point, going to this point. See, if I start on the left, I can tell that it's going up. It's going to be a positive slope. But you're going to find a couple things. First, you're going to find the rise. Oops. I don't want to do an arrow here. Sorry. You're going to find the rise, which the rise is the vertical change. So from point to point, how much did it change vertically? We call that the rise. We call that the rise. And you might remember from 8th grade or 7th grade even, rise over run. Does that sound familiar? In your fine slope, you do rise over run. Rise, if I told you to rise out of your chair, that's a vertical change, okay? So how much did it go up or possibly down? So because it's a vertical change, that what we're doing is we're finding our change in y. Okay, so tell yourself how much it went up or down. So that's the first thing you'll find. You'll look for the rise. So from point to point, how much did it go up or down? Okay. And then you will go ahead and find the run. Okay, we call it the run. Run is the horizontal change. So I'm just going to put a horizontal arrow like that. So how much did it go left or right? That is your delta x, okay, because x runs horizontally. So that's how much it went left or right. Okay, so find your rise, find your run. Those are the 2 key pieces of information. After you find your rise and your run, you're going to go ahead and calculate change in y over change in x. Look familiar? Should. That's rate of change. Rate of change is the same thing as slope. In fact, we should probably write that right here. Rate of change is literally the same thing as slope. Okay, so you are finding change in y divided by change in x. Now, when your parents learned this, they learned it as rise over run. When I learned it as rise over run. But really what you're doing is you're finding the change in y divided by change in x. Okay, so calculate change in y over change in x. And then last thing to do is to simplify. Simplify the slope. And why you're doing delta y over delta x is you're doing that to find the slope. So change in y over change in x to find slope, and then always simplify the slope. It is very possible, extremely possible, that your slope will be a fraction. Okay, it could be an improper fraction where the bigger number's on top, that's fine. It could be just a normal fraction. It can be negative, positive, doesn't matter, okay? So for these notes, I am going to do just one example with you down here because I don't want us drawing a bunch of graphs. So we're just going to draw one pretty one. Okay. So big graph, label your X and Y. And as neatly as possible, I want you to go ahead and do your little tick marks. I'm hoping that you can go at least out to like 4 or 5 each way. Okay. Pause the video if you need more time than that. Okay. Now, usually the line is graphed for you, but because it's not already graphed for you, we have to graph it ourselves. So I'm just going to give you a few points and then we'll connect them into a straight line. So please put a point at -2, 3. Please put a point at 0, 2. And please put a point at 4, 0. So once you have those points in there, find something with a straight edge. It could be a piece of paper. If you don't have a ruler, everybody has a piece of paper. Just find something straight, line it up with those dots, and then you're going to go ahead and connect them and put arrows at the end. Okay. Once again, usually the line is there for you, but because of the situation, we got to draw. Okay. So if this was the line given, the first thing you would do is identify 2 points. Well, I already gave you a couple points just so you could make that straight line. But go ahead. Here we go. Let's use these 2. I'm going to use this one and this one. Okay. Identify 2 points. Starting from the point on the left. So I'm going to start with this one because it's the point on the left. I'm going to find the following. I'm going to find the rise and the run. The rise is the vertical change. So from here to here, I want to know how much I have to go up to get there or down to get there. Now, in this case, this is a descending line, so we would be going down. So how much do we have to move down? Move down 1, 2, 3, now that they're on the same level. So your vertical change, your rise, was -3 because you had to go down 3, okay? So my change in Y was -3. Now let's go ahead and calculate the change in X, which is called the run. So from here, it's like how many little hops over do I have to do? How many horizontal spaces do I have to move? I have to go over 1, 2, 3, 4, 5, 6. I have to move over +6 in order to get there. So my change in X, which is called my run, was +6. Okay, so now I'm going to calculate. I'm going to take my change in Y, which was -3, and I'm going to divide it by my change in X. So this would be your calculation here, -3 over +6, but you're not done. You got to simplify. -3/6 is equal to what? Simplify it. That's half, but do not forget your little negative sign, okay? So final answer would be that your slope equals -1/2, all right? Now the last thing I want to do, because I don't want you to have to draw a million graphs, is I'm going to go ahead and show you kind of what your potential homework and practice would be, which is going to be on Delta Math.
All right, I hope you can see my screen. I am currently on Delta Math, and this will be part of your homework tonight. So we're going to go ahead and practice this. Let's read the directions, though. Draw a line representing the rise and a line representing the run of the line. State the slope of the line in simplest form. So rise and run, remember that's just the vertical change compared to the horizontal change, or change in Y over change in X. So I'm going to zoom in so I can actually see some points here. I see a point there, and I also see a nice point right there, okay? But we don't want to go straight there. You're actually going to need to show like the stair steps, okay? You need to show the rise and the run. So to delete that orange line, you just click right on it. So instead, I'm going to see the vertical change. So it looks like it starts down at -6 on the y-axis, and I have to go all the way up to -1. So that's 1, 2, 3, 4, 5. It went up 5. So down here at slope of the line, I'm going to enter my change in y. It went up 5, which means it's +5 for your vertical change. I'm going to divide that by the horizontal change, which is the change in x. A lot of people call it the run. So from that point to our ending point, we want to calculate how much we had to go over. Looks like we went over 1, 2. And since it was 2 units to the right, that's a +2. So I get 5 over 2. Question is, should I divide? Should I make it a decimal? No, you actually want to leave it as a fraction because we like to see the rise and the run. So 5/2 would be your final answer. One thing I always check is I double check if it should be positive or negative. So if you look at that blue line that's graphed, read it from left to right. It is going upwards from left to right. It is increasing. Therefore, your slope should be positive. So 5/2 makes sense. So we're going to simplify. Going to say yes. Cool. New problem. Okay, right away I notice that this line is descending. It's going down. So I know I'm going to have a negative slope as my answer. So pick any 2 points. So maybe I want to go from here to here, okay? But I have to do the little stair step thing. So I'm going to start with the point on the left, towards the left. How much I have to go down? Well, I would go down 1, 2. Since I went down 2, that would be -2 as my change in y, okay, as my rise. It went down 2. Now I'm going to divide that by the run, which is the horizontal change. So from that point to that point, it went over 1. Now since it went to the right one, it's just a +1 on the bottom. So the slope of the line is -2 over 1. Now this is a case where if you divide 2 by 1, you get a whole number answer. -2 divided by 1 is just -2. And that's totally fine if you want to, I don't know how to delete this. There we go. Nope. Oh my goodness. I'm just going to leave it. So it'll allow it. It should allow it. Okay. But you could also write it as -2 and you can see that right there. Okay. So this is going to be your entry task question. I'll locate 2 good points for you. Okay. But you're going to have to figure out what the slope is. So stare at that, write it down in your notes, but that's going to be the entry task question. What is the slope of this line right here?